Hello, I'm Brent Ferris from the Beta Man Studios, and in this video I wanted to do something a little bit different. I wanted to make some teleporters so that when your object goes through one, it pops out of the other. And this is not so much of a teleportation technique as it is a physics technique. So I just wanted to demonstrate how to get this physics to kind of be the simulate popping out of a portal or something. I don't quite know how to understand it, but you'll see once I get it. So here I have a sphere that I called player, and I tagged it as player. And I have a plane called left, and I have a plane called right, and a light to make it easier to see, and of course a camera that is looking down, kind of angled towards it. So let's go ahead and get started on programming. I'm going to create a C# script. I'm going to call it teleporter, and I'm going to open it up. Sorry, I paused the video for a second to let this thing load. So the first thing that we need is a public game object. This will be the other plane. We're going to put this teleporter script on a plane, and it has to identify the out plane where it's coming out of. So I'm going to call it just other end. And we need a private bool. Teleporting is equal to false. We need this just for some housekeeping. We don't need the update or start functions. So let's just go right into, we have two functions that one is going to be a private void on trigger exit collider C. And by the way, before I go any further, I want to make sure that you have your plane here. Both these planes must be trigger. So is trigger checked on both of them because they need to be triggers for this to work. Oh, and the sphere has a rigid body, just a standard rigid body, no special things, no constraints, nothing, just a rigid body. So now inside of our onTrigger enter, we're going to say if c.name is equal to player, so if the sphere passes through it, and if not teleporting, then we're going to do a function. We're going to call the other end dot get component. We're going to get its teleporter class, and we're going to call a function teleport to. We haven't created this function yet. c.gameObject will be passed. And right after that, we're going to be teleporting is equal to false. So let's create this other function here. So we're just going to do a public void, paste the name, and take in a game object obj. So then we're going to need to first set the object's position to our new plane. So we're going to say obj.transform.position is equal to transform.position subtracted by, this is a little something special that I did. It's not necessary, but I wanted them to, when it pops out of one end, I want it to go up to the same exact height as it started. So I found that I needed to do this. I needed to do the transform.up multiplied by this arbitrary 0.65f. And there's an explanation to this. The sphere goes below the object when the physics happen, and assigning it to its position is its middle point, so then it actually gets more force coming out than it normally would. That's why we have to set it lower, down to about where it would be when it teleported. So obj.rigidbody.velocity, and if you need an explanation, I might go over that at the end of this video. About what I said a second ago. So then we're going to do transform.up multiplied by the obj.transform, or we don't need to do transform, obj.rigidbody.velocity magnitude. Magnitude is just a floating point number that describes, well, it's, if you know your vector math, then you know what a magnitude is, really. But it's basically, in simplest form, it's just a floating point number for the speed of the object. And then we're going to put our teleporting equal to true. So now we're going to jump back into Unity. We're going to drag our teleporter script onto both planes. We're going to select the first plane, which is left. We're going to drag right into its other end. And then on right, we're going to drag left onto its other end. Now if we hit play, this object will go through one and pop out the other. Now if I put my cursor here, see it's about the midpoint of the ball. If I leave it here, you're going to see that it's going to appear on the same exact point. And there you go. So now it's kind of teleporting through one and coming out the other. Now, since this tutorial is basically done, you can run off here, but if you want an explanation on why I needed to do minus 0.65, I will show you. So we will first jump over into our script, and we're going to put a breakpoint. We're going to do debug.break, which basically just pauses the editor. So I'm going to put this up here, and I'm going to break it again after. So I'm going to show you the difference between without subtracting that position and with subtracting that position. And I'm going to break in the very beginning. So here's 3 breakpoints, right? So what's going to happen is it's going to break before it teleports. You'll see where it's at and underneath the plane. It's going to break again after it sets its position, and then it's going to break again once we subtract 0.65 from the transforms up. So if I hit play, it's going to go down and it's going to break. It looks like it broke late. It teleported down to there. Odd. Okay, so let's just go ahead and let's see if we can break it before. I wonder why it broke after. See, it's breaking late. So let's actually break it just before this function, or just after this function, I guess. You don't have to do any of this. This is just for my explanation. So, doop-de-doop. Still breaking late. Let's just not set the position, shall we? And the velocity and none of this. So, I guess I'll have to do this one step at a time. Now I don't need this break anymore. So if I hit play, it's going to go down. And you see where it's at. You can see it's actually a little bit lower than the plane here. Here's the plane, and you can see that it's below down here. Now I'm going to stop playing, and I'm going to put a breakpoint just after I set the position to the transforms position. So I'm going to hit play. It's going to go below, and you can see if I set the position, it goes right to the middle of the plane. So if I added the force, it's actually going to go higher than it normally would each time, because it doesn't start off at the same Y. And that's why if it went down, it would go up higher, and then it would go down and go up higher, and it would keep going higher to infinity. So I wanted to prevent that and make sure it went to the same exact spot. So I'm going to undo this and this debug down here. Now you can see once it goes under, bam. You can see that it's a little bit below the plane, just like the other one. Maybe a little bit too high, but 0.65 pretty much does it. So now it starts at a good point. And just to drive the point home, I'm actually going to uncomment this. I'm going to set its position to that, and I'm going to run it, and you're going to see what I mean by it's going to get offset. So you can see it's at my mouse cursor about there was the midpoint. Now the next time is going to fly higher than the midpoint, and it's going to fly higher, and it's just going to keep getting higher and higher and higher. So that is why I added the transforms up 0.65 just to put it down below. And the reason I use up instead of just subtracting on the y is because these planes might actually be angled. Hey, I might say, well, let's do something cool. Let's just drag this over here and rotate it. Now let's hit play. Chow. Pop. Chow. There it goes again. And it's going to go further because it went through the... It's just like any kind of Portal game you play. It's going to get faster and faster because the drag is actually further and further. So whoop. And then further it goes. See if I can catch it. Yeah. See if I can catch it again. There we go. So there you go, some simple portals, but most of all, like I said, this is about the physics and how to get the magnitude and make it pop out of things. And of course, I could always do some classic portal. I'm probably gonna have to do some more checks than I am currently doing. Obviously, I should just then grab the right plane and put it there. This at 0. No, don't put that at 0. Sorry. Grab this one Z. It's on the same Z, so now all I have to do is raise this up and grab both of them. There we go. And I guess the camera over here will watch the bottom portal, and I'll watch the top portal over here. So goes in, pops out, goes in, pops out, goes in, pops out, goes in, pops out. Go faster and faster. Up. Went too fast. Went right through the plane. Which, of course, if you ever... Hey, look, I can do it this way. If you ever need to do that, just swap out this mesh collider with a nice box collider, I guess. Of course, you don't want the box... not cube. What am I doing? Component, physics, box collider. You don't want the box collider to go below the plane. You want it to go above the plane because you want the exit point to be at the same point, I guess. So we make the Y really high and pick it up to make sure that it's at the bottom. There we go. And that's good because we're only worried about the bottom one. So now we can hit play. Because, oh, don't forget to make the collider a trigger. And we can hit play. And now that box collider is going to catch it for sure. And there we go. I can go really fast without skipping the entire thing. Eventually it's going to skip the entire thing. You probably want to pause the magnitude to make it only go a specific velocity, but there it goes. Now it's just blinking. So there you go. There's some physics fun, and if I kept it going, it would eventually look like it's going backwards because it's so fast. That's why I started to slow down. But I think that's it for this video. I hope you enjoyed it. Let me know if you have any ideas for other videos or questions. I'll be willing to answer them because this is a lot of fun. So until next time, have a good night.